Welcome to another unit of the ISM Exercise Set Statistics 2. This time with a unit on the coefficient of determination and the F-test. Let's have a look at the exercise. For 5 selected paperback books, prices and page counts are collected. As a result, from linear regression, you get the following regression line. That's y being equal to 0.0502x minus 7.6696. Here x is the number of pages in a book and y is its price. Our task now, part A, assume a coefficient of determination of 0.83 and conduct a suitable test to test whether the model, with an acceptable probability of error of 5%, has significant explanatory power. Part B, argue why an increase in the acceptable error margin, i.e. 10%, will not change the result of A. So first off, what we need to do is perform an F-test. So we need the F-statistic, the test statistic. This can be calculated in this context as r squared, which is given as 0.83, divided by k, the number of independent variables, which is 1, divided by 1 minus r squared, so 0.17, divided by n minus k minus 1. N is the number of observations, so here we have 5 observations. K again is 1, so we have 5 minus 1 minus 1, so here 3. And this gives us an F statistic of 14.6471. And in addition, we not only need the test statistic, we also need a reference value or critical value. And this is given here as f, k, then n minus k minus 1, and 1 minus alpha. We know from above k is 1, n is 5, and from the exercise text we get alpha is 5%, the acceptable margin of error. So here we need to look up the value f130.95 in the tables of the F distribution. There we find a value of 10.128. Then we compare this reference value and the test value, get as a result that our test statistic is larger than the reference statistic. This means our H0 hypothesis can be rejected, and the H0 hypothesis of the F-test is that the model has no significant explanatory power. So here we can say that with a 95% chance, or with 5% error probability, our model has significant explanatory power. So much for part A. In part B, we will ask what happens if the error probability is raised. So if an alpha error of instead 5% is set to 10%, 15, 20%. Well, what we are going to see, if we take a critical look at the tables for the F distribution, we see with an increase in the alpha error, the test value, the reference value is always decreasing. So the chance of a test being successful, or the test statistic being larger than the reference statistic, is becoming increasingly more likely. In other words, here in our case, the test statistic already was larger than the reference statistic. So if the reference statistic only decreases, our test statistic will remain larger independent of by how much we change the reference statistic. Only if the margin of error is decreased, then we might get a problem. Then at some point this might become insignificant. But however, whenever you decrease the reference statistic, and this is done by increasing the acceptable margin of error, the chance of actually the test succeeding and the test statistic being larger increases. Well, that's then already the conclusion to this part of the exercise. And I hope you enjoyed listening to this exercise. And if you want to see more, can see more in the corresponding exercise set or via the corresponding playlist. I say goodbye and see you next time.